Well, hello. Good morning. Echo. Hi. Hi, everybody. How's things? What's shaking? It's Friday. Can't believe it. I'm so excited. Um, Friends, it's gonna be fun. I'm on tomorrow. For those of you on the in the know, if you've been in the show before, the last few days, tomorrow, I'll be. I'm on my kids on spring break, so we're going on a little family break, family vacation. So I'll try and do some streams next week, and I've got a video lined up. But basically, it's probably going to be a little slim pickings uh, tomorrow and next week. But I'll be back. Don't worry, I'll be back as soon as humanly possible. I just don't know if I can commit to doing 2 hours every day or whatever it is I do. In the meantime, but I'm excited about today. I'm excited, and we have. I mean, there's so much stuff I want to cover with y'all. Um, I just sit every day. I sit down and I look at the schedule. I'm like, okay, what can we cover next? And some things I'm more familiar with than not. Yesterday I got to see an old friend. Yesterday, a friend from Belgium um, came to San Francisco, and so good evening, good morning, hello, hi. I see all you wonderful people. Good to see you, Ahmed. Good to see you, Diva. Good to see you, Michael, and Daniel. And yes, good evening, good afternoon, good morning. Um, so anyway, yeah, I'm just I got my friend from Belgium was in town yesterday, and it was great. He worked on a workflow engine, and I was just thinking that's another topic I would just love to do a few episodes on, whenever possible. Obviously it's not like I can. I don't know when it'll happen, but yeah, just an amazing topic there, right? We could do workflow, and actually we even had Mohammed. Oh, oh yeah, Rick and Morty. Oh yeah. um, Sorry. Yes, good question. So we are covering the DSL-based implementation of Spring integration. I ever so briefly looked at the component model, and we looked at what did we look at? We looked at the component model for a service activator, right? Pretty, uh, pretty simple, pretty, pretty simple example. But basically, for most of my stuff, I do I do uh, the DSL. Okay, let's see. Oh, hey. By the way, just got tweeted right now. I can confirm I'm doing a webinar with Vaden soon. Some a webinar with Vaden in the spring about Spring Boot 3 and Vaden. So that'll be fun. Um, hmm. Yeah, so that'll be fun. So lots of good stuff. I want to do workflow. My friend from Belgium worked on a workflow engine, and I love workflow. And we even had Mohamed Benassin, the lead of Spring Batch. He worked on a project called Easy Flow, right, which is a nice workflow engine. And obviously, I'm a committer to Flowable, which is another amazing workflow engine. So I just feel like that'd be kind of a fun one as well one day. There's just so much stuff we could talk about, friends. But today, well, hello, nice way to end your Friday. I'm starting my Friday, but I appreciate you being here. It's a nice way for me to start my Friday, and the best way, actually. Like I said, coffee and code every day. If I can do that every day, I'm a happy guy. Here's to y'all. Now, I drink coffee, way too much coffee. And by the way, but I meant to go back to this. Do you like the DSL implementation? Because I love it, and we even had Artem Bilan, Spring Integration Lead, Artem Bilan on the show just a few days ago, and he's the person who created the DSL, as we know it. So good stuff. All right, friends, let's get right into it. So I think we okay, split aggregate. We did talk about that in one of the first. Guinea. Wow, thank you. Nice to see you. Hello. If you wanted to do split and aggregate, I think we did talk about that recently, actually, right? Like I don't know, a few days ago in the last one of the last videos, I actually did an example. But it's pretty simple. As long as you've got the headers in place, then the Spring Integration framework will do it for you. So and if you go back, I think it's like I don't know. I mean, I don't even all blurred. It's all blurred to me because we do so much stuff here. So let's see. Was it the part two? Maybe I think it might have been part two. Go check out part two, and there's a whole thing. Not now. You have to stay with us now for this one. We need all the energy we can get. But check out part two after this stream. Um, Part one and part two are like the basics. We look at the core patterns supported by Spring Innovation, the core DSL, the approach, all that kind of stuff. And then by the time we get to the next episode, it's Artem Bilan, who is like I said, the lead of Spring Integration. And then we looked at the Apache FTP server because it gives us an FTP server that we can use for file-based integration, which is what we looked at yesterday. So it's all part of a plan. It's not a great plan, but it's a plan, and hopefully it's working for you. Okay, so sharing my screen today. Oh, I'm so excited. So excited. So much stuff. Okay. So where are we? Where did we leave off? I don't even remember. So I think we had our code, GitHub, Coffee Software Show. The filter bit in the middle though gets tricky. Are you saying you've got like a split and then you do a filter and then you want to do an aggregation or to release the message group? Yeah, that might be interesting. If you don't have all the messages there, it'll never complete, right? So yeah, I guess I would just, it'd have to be a timeout, right? Okay, so yesterday we did files FTP integration. Did I? Oh, okay, right. We have, by the way, for those of you who are wondering, this code, at basics, in the basics module, this code also looks at file-based integration and relies on an FTP server that we created in the Units repository. Right. So by the way, yesterday on yesterday's stream, things broke, and I didn't know what it was. I couldn't figure it out, and we didn't spend a lot of time on it. We literally just I tried one thing and it didn't work. And I was like, oh well, end of story, right? We were basically done with the day anyway. It turned out all I had to do was upgrade that code. Remember, we built the FTP server like 2 days ago. So on Tuesday, today's Friday, so yesterday, Wednesday, I think we started the FTP server, right? And that code was using Spring Boot 3.0.4, which is very old, right? It's already been succeeded by Spring Boot 3.0.5, which came out yesterday. And that had a fix, actually. Little did I know, it already fixed the issue. So if you get the code now, which I'll do right now anyway, because I need to. Okay, here's this. If you get that code now and compile it to a native image, it just works, right? So desktop, git clone, blah, blah, blah. And let's code Gradle native compile. And we'll let that do its thing in the background while we spin up while we clone the Spring Innovation code and we start today's journey. And we're going to cover, we're going to look at a bit of an anti-pattern today, right? Which is a shared database-based integration, right? It's not pretty. Nobody likes to do it, but sometimes you have to do it. Now, for those of you, I say it with some disdain in my voice, and I hope most people appreciate why. But if not, let's talk about that, right? Your database is one of the most complex parts of your system. It is the brain of your system, right? Well, at least it's the storage part of the brain. It's the thing that holds your data, right? And you shouldn't expose that to lots of different clients and services, right? Because that is fragile. Hey, are these sessions recorded? And if so, could I please provide a YouTube channel? Yes, it's in the top of my screen there. YouTube.com/at coffee software on the top of my, in the green buffer at the top when you're looking at my video right now. I hope that's what you're seeing. But yeah, they're recorded. They're all on my YouTube channel. Please subscribe, like, and subscribe. You know, it's just there's no all I have is the sense that people are appreciating the content. You know, like the YouTube videos they're fun. They're exciting for me. I learn stuff. I would be writing this code anyway, so it's nice to have some people with whom to write code. But the YouTube videos are also a lot of investment. So I'm hoping people will at least subscribe. That way, you know, when there's new stuff, we can all enjoy the adventure together. Okay, so your database is one of the most expensive, most intricate, most involved parts of your system. It's like having your organs, you know, on the outside, right? You know, with rare exception, you don't want to do that. Hello from Mongolia. Hello, wow. Hello from San Francisco. I appreciate you joining us today. So you don't want to have that hanging out and like exposed to everybody, right? And especially because if they change something, you need to synchronize that change with everybody else that is using that database, right? That becomes very problematic because there's so many fragile states that you have to manage with the database. At least with the message queue, the only thing you have to manage is the shape of the payload. That's it, right? You send a message, it has a payload, the envelope, and then there's a payload inside that envelope. Synchronizing that should be pretty simple, right? Standard in, standard out, message in, message out. But synchronizing and agreeing upon the shape of your data store, the thing that is the living, breathing sort of representation of your business. No. That's dangerous. And so Amazon, very famously, you know, more than a decade ago, they realized that all communication between services needs to be done in terms of an API, right? Some external thing. You don't just share databases. And then this, of course, led to like microservices. You have small, singly focused services that babysit, that manage, that control their own databases. And the idea here is those APIs are how you're supposed to communicate. And that's true. If you start a project today, don't do what we're going to do today. Like if you're starting a brand new service and everything is brand new, net new, greenfield, clean code started today in 2023, then you shouldn't need to do this at all. This is a bit of a hack. There is one exception to that, which is a few weeks ago, I did a video on, let's see, coffee software. I did a video a few weeks ago, let's see, called Postgres MQ. Oh, 2 months ago. Gosh, time is flying when you're having fun. So can Postgres replace your messaging queue, right? And in this case, you're using Postgres as a message queue. So that's, and we might even look at that again today, just because that's kind of awesome. Basically, you can use PostgreSQL as a message queue from Spring integration. And in that way, you're treating it in the same way as you would RabbitMQ or Kafka, right? So you're still dealing with an envelope. You're not really sharing the database. You're exposing the connection credentials to your database, just like multiple clients and servers would also have to have the same credentials to your RabbitMQ. But basically, you're not sharing state. You're publishing messages back and forth using Postgres' message queue support. Okay, so yeah, today you want to like have isolated things. Where are we? Download desktops. Okay, CD. Let's go to Spring. Okay, so let's create a new project here. Start that Spring.io. We're gonna create a new project and we're gonna call it database integration. Right? Database. Do we want to do? I guess we can do. Let's see. Simple DB integration. And we want to, I'm going to use Postgres because I just happen to love it so much. We'll use integration. We'll use the Graalvm support. We'll hit enter. Okay. And by the way, Spring, a couple things. Yesterday we released Spring Boot 3.05. That supports Java 20, right? I've been talking to you all about this. Java 20 is amazing. It's out. You can get the latest bits. It's on SDK Man as well. So SDK list Java. We released Java 20 on March 21st. yesterday we released Spring Boot 3 officially supporting Java 20, etc. So there it is. Java 20, you can do, if you're not using SDK Manager, SDK install Java that, right? And you'll get the version of Java that you want. Very easy, and that works on all Unixy machines. So if you're on Linux or Mac or even Windows subsystem for Linux on Windows, that works just fine. Okay, so that's one thing. The other thing is today is the 24th of March, which is now the 19th anniversary of Spring Framework 1.0 GA. So this is Spring Framework 1.0, from March 24th, 2004. We released it, and you can see Spring looked very similar to what it looks like today, even back then. I mean, you'll recognize a good many things in Spring Framework. They've sort of always had a sense of what should be there and what should be supported. Some of these things we've talked about actually in our discussions. So AOP we talked about JDBC ever so briefly. Flexible WebMVC framework, we talked about that. Application context, we even talked about Hash and Burlap, which are now basically deprecated, but you could use them. RMI is also not supported. JDBC, we talked about that. We talked about Hibernate. We don't use it very much, but you could. Right? A lot of these things, common attributes. By the way, these are annotations before Spring Framework had Java 5 annotations. So Spring Framework was built, on Java 1.3, right? So Java 5 is what introduced annotations. That came much later, a few years later at least. So yeah, like all this stuff, it's been 19 years since Spring Framework 1.0, right? I mean, it's just amazing how far it's come, of course, but it's also incredible what was right out of the box, correct from the get-go. Okay, so we've got our simple DB application. We need a data store. So let me see. We've got this. Move that to the desktop. Okay, we need that. And we need a Docker Compose file. So I suppose we must have a few of these laying around. Your question: would I consider building a Spring Boot app using a reactive stack with CRUD operations during a live stream? Yeah, I mean, yeah, I could do a live stream, sure, but I've done just not right now, not today, but I've done a million videos on that that you might watch. Well, I mean, for that matter, you can use Spring Data REST. Just create a reactive CRUD repository and use Spring Data REST, and there you go. There's your CRUD HTTP API, no problem. Okay, so what we were looking for my Docker Compose file. So let's code Spring Boot 3. There's got to be a Docker Compose in here somewhere. That's not what I wanted. I want something. I just needed Postgres. You remember using XML to define means? Me too. I think we even covered it in the first video when we did our Let's Code Spring Boot, and then quickly moved on because I don't encourage it. Is this it? Yeah, this one. Okay. Copy and paste all that. Yeah. YAML. Okay, so we'll. Okay, majorly oversized. Good. So Postgres, we just need Postgres, nothing else. So compose. Oh, I need to start Docker, and that's important. I also need to delete like everything here. This might take a minute. Okay. Docker compose up. It's booting. Okay. Look at that. Okay, good. So we have our SQL database. We have our code. Let's just start using it. Let's think about this. So let's suppose we have a database with some data that we want to integrate. So whenever there's a new file, whenever there's a new row, a new record in our SQL database, we want to be notified of it, right? And so this is what we mean by shared database integration, where some event in the database is interesting to us, and so we want to be able to get notified of that event. Okay, Spring Integration has support for this. As before, we need to bring in the appropriate adapter. So we're going to bring in Spring Integration JDBC. Whoa! I chose JDBC on the initializer, and it already brought in Spring Integration JDBC. That is cool. I didn't know it would do that. This thing is like amazing. So look at that. I didn't choose. There's no way to choose Spring Integration dash JDBC, but somehow it knew I want JDBC. I want Spring Integration. Therefore, bring in Spring Integration JDBC. Brilliant. Okay, so I don't need to do anything there. And Spring integration, well, actually, here we can do, let's just create the bean. So bean integration flow, JDBC inbound flow, turn integration flow dot from dot get, and then we're going to say from JDBC, I think it's just JDBC dot data. Let's see, database. JDBC. I'm trying to see where the DSL is. Oh, here we go. Spring integration properties. No, that's the auto configuration. Spring integration. Let's see. What's the DSL? Spring integration. JDBC. Inbound adapter. Inbound channel adapter. So there's this. This is what I remember using. What's the Java DSL equivalent of that? That's what I'm trying to look for here. Okay, inbound channel adapter. Outbound inbound channel adapter, JDBC. Okay, batch update, outbound gateway. That's a bit of a bummer. Is there a way to use the DSL? So I mean, there's usually, let's see, file. If we added Spring Integration file, you'd expect a thing called files. So you can files. Okay. See, that's what I'm looking for. I'm looking for the equivalent thing, public abstract files. So it's org Spring Framework file. So let's see, where's org Spring Framework JDBC? Org Spring Framework JDBC. Okay, what's it called? Channel JDBC polling channel adapter. So I guess that's what I guess I have to manually instantiate that, which is fine. It's not a big deal, but okay, let's just do it that way. So we'll create a bean of type JDBC polling channel adapter. Oh wait, what was that? Oh, parse it. Okay. And then you pass in a data source and a select query. And of course, now that we have our Docker Compose file up, we need to point our application to the data source. So Spring data source URL equals JDBC Postgres localhost Postgres and username Postgres and password. Okay, and then use the data source. Then we want to provide a select query. So select all from customer. So let's just create a table like that. That should do it, right? We just inject that. So the JDBC pulling inbound adapter. We use that here. Okay, so we have there, and we're going to pull, right? Remember we talked about the pullers. So the pullers are the thing that describes with what frequency we ask the question, is there any new data? So here we're going to say we want to request, every 1 second, we're going to pull that thing. And then when we get the response, I don't even know what the payload would be for this. I suppose we should configure some other things here. Let's see, var JDBC, JDBC.set row mapper. Aha, yeah, this is what I was kind of looking for. Like, I need to have a way to take the results that come back, customer, integer ID. Okay, so we're going to use just a very simple row mapper here. We'll create that. So class customer row mapper implements row mapper of type customer. We saw this when we looked at the regular Spring JDBC support in the Let's Code to Spring Boot series, right? Just the row mapper is just a classic JDBC template mechanism. And your job is, given a result set and an offset, to return the appropriate reference that you want, right? The row, to map the row. So we're going to feed, this is you can inject this actually. You can just make this a bean if you have any state. I don't happen to have any state there. It could just be a lambda, but whatever. So here's this. Okay. Now return JDBC. You need the SQL database, so let's create the schema.sql insert. Create table if not exists customer ID serial primary key name varchar 255 not null. Okay, and here you need to be very good about using smart schema. You want to make sure that you're not getting duplicate messages. You could try and solve that in the framework code, but it's better that you don't have the duplicate message in the first place. And so I want a key, right? I want to make sure that I have a key that dedupes the data. In this case, I'll just use the name field there. Okay, so let's see what happens if we restart this application. I don't even know if anything is going to compile, let alone run. So handle, we should get a record of type customer if we create a generic handler, right? If we did this correctly, the payload should be of type customer. So all I want to do at this point is just log everything out, right? So payload, and then headers dot for each AV A B. Okay, very simple. It's a little lambda. Start. Okay, something has gone awry. Oh, because I don't have I'm not telling. This is a actual third-party data. It's a database running on a separate port. It's not embedded, so I need to tell it to init always. By default, it just does embedded, but I want to do always, so I'll just do that. Start. Okay, seems fine. Let's see when we go to our SQL database, what does that give us? PG password equals Postgres. SQL U Postgres H localhost, and the schema name is Postgres as well. Select all from customer. Nothing in it, but if we look at the schema itself, you can see we have a key name. We have a constraint there, customer name key. Okay, so what we want to do is an upsert, right? So for example, if I tried to do insert into customer name values Josh, that works. But what if I try it again? It fails, right? So we want to make sure that when there's a constraint violation, it just does nothing, right? So that way the code doesn't break catastrophically on the producer side, but also we get integrity of our data on the consumer side. Okay, so we want to do okay, insert into customer values on, what is it? on conflict, do nothing, I think, something like that. So nothing, but if I do what, there you go. So it's saying if there's any upsert issues, then just do nothing. That way it doesn't bail out. So if I look at the data, select all from customer. There you go. I got 2 records. Okay. And by the way, you can see it. If I insert those records, like 5 different, well, 4 different times, right? But because it incremented the ID from 1 to 4. Um, so what just happened there? There you go. So we've got 4 records now. So what is this having issues with? Class array list. Array list cannot be cast to class customer. So am I getting a? Oh, it's giving me the payload is an array list of customer. Interesting. It's giving me the results. So if we go here, var var c payload, we want to say, actually, yeah, we can just print out payload. I guess that's fine too. Okay. All right, good stuff. So restart that. So you can see it's requerying the same data. So we've already got a problem. It's going to redeliver the same message. So you want to have a query that's a little bit more intelligent, where it says where processed is false, is false or equals false, right? Something like that. So you want to have like a state flag to make sure that you've acknowledged the processing of a given message. And so let's do that. Well, here's our schema. Processed Boolean default false. Okay. We want to drop the table and rerun this. Okay. We can insert some records. There you go. So select all from customer. And we still have the same problem, which is that it's going to continuously give us the records in response. It's going to continually pull that database, which is not good. We don't want to do that. So now what? Well, we've looked at the basics of this inbound adapter. Let's see what else it can do for us, okay? So set update per row. So let set update SQL. Oh, so that's interesting. This is an inbound adapter. So that means the data is coming from the database into our Spring Innovation code. Does this allow us to then mark a message as having been seen? Set a flag to update per record, not false to false. Update. Okay, update. Set update. Set select query. Interesting. Let's see here. Does it have a way to update the yeah, you can update the processed row. That's really cool. Okay, so where is that? Where is that mechanism? So here's the select query. Select updates. Okay, update per row. Set update SQL parameter source factory. Okay. If payload does not equal null and this update SQL is not null, then if it's update per row, then for each, okay, so I don't think this is the most efficient thing, right, to do update per row. I think it wants you to do a multi-dimensional query, but for now, let's just make it as simple as possible. Let's say yes, update customer set processed equals true, where ID equals this, right? And then we want to say JDBC.set update per row is to true. And then we will need to provide a prepared statement, right? So update new SQL. There you go. So we're going to create, so what is it doesn't have an, is this supposed to be a customer? What is this? If input instance of customer. Then we create a SQL parameter source. How do we do that? Right, we want to create a map SQL parameter source. Sure. Static bean property, a map SQL parameter source. Okay. Return new map SQL parameter source. Then we have a map of string names and values, or just param name and value. So ID, and then the value is customer.id. Right. So that seems reasonable. Does it ever get here? Let's find out. The input is not a customer. Okay. That seems fairly reasonable. It looks like it's going to work. So update customer, set process equal to true. We want to return a map with keys and values that get then mapped to this update expression. Does that make sense? It feels like it should make sense. I don't know. It might be wrong. I haven't done this in a decade. Nope. It's not working. Never trust a query. Given one parameter but expected 0. Wait. Ooh, that's nice. Okay, wait. So what happened? Select all from customer. Process is equal to true. Okay. So now insert into customer. Let's take some people from the chat here. Uh, wow. Okay, it's live. Oh, and then what about Mike? Okay. Ahmed. So if I look at all these records now, they're all marked as true. So it's just like yesterday when we looked at the inbound file, the file inbound adapter. There was a way to delete the source file so that you could so you wouldn't get the same message redelivered. And you have the same thing here, right? We have the ability to, every time we get a new message, to update the source so that it doesn't get reissued, right? That's pretty cool. So we're actually, I haven't tried this in probably since I wrote my Spring Innovation book, my Pro Spring Innovation book for A-Press back in let me see, Pro Spring Integration. This one. Do not buy this. I mean, it was a good book, but it makes no sense today. It's how old is this book? 2011, right? 2011. That book came out in 2011. Oh, here. April 6, 2011. So actually we're closer to 12 years. we're a week and a half away from 12 years old. This book is now, right? So Pro Spring Innovation. It was good. It's just not good now. There's no Java config. There's no Spring Boot. There's no there's no Java DSL at all. There's not even an annotation component model at that time. So it's been a while. Okay, good. So this is really cool. This is like a JDBC inbound adapter. Now, what if I wanted to do something to write out the data? What if I wanted to do some processing? So let's start. We've got something useful. Let's put this in the Git repository so I can start versioning the code. So get out of there. Desktop, let's go to Spring Integration. Okay, make clear DB database. Database, copy or move downloads. Simple. Okay. CD simple. RMRF build. Git add this directory. Okay. By the way, we also kicked off that Apache FTP server build. It is this finished in 47 seconds. So that's been finished for a long time now. Let's see here. Ta-da! There you go. 49 milliseconds to start up our Apache FTP server, which has Spring integration in it and all that stuff. So if you do lftp ujlone pw localhost, but let's see. Desktop. Hello. There's no there's no content there. So actually, I wonder if I can put the recording. It's pretty big. But desktop recording. Oh, it's taking its sweet time because I've got rate limiting, right? I've got only a certain rate per second. But okay, yeah. So clearly that's working. I transferred a file. If I go to the FTP server, which is built on Spring integration and Apache FTP server in native code, received store recording.mp4. This is the event. Remember, we got that event from Spring integration yesterday. So this is all yesterday's follow-up stuff. I just wanted people to see that this is now working, and it's a native image. This image is, what is it called? FTP server. What's the PID? Where did the PID go? It's in the beginning. The preamble. Here we go somewhere. So PS-O RSS. 102 megs, right? That's how much RAM that thing is taking, despite the fact that it's a Spring application running a whole embedded web server that starts up in less than in 1/20th of a second, right? It starts up in 1/20th of a second. It's 100 megs of RAM instead of like a gig of RAM or something like that. So good stuff. Well done, everybody. Good job. Okay, so we've got this code here. Let's shut down our FTP server so we don't forget about it. Um, what do we not need? I'm trying to close Windows here. Good. Here's our database integration idea build.gradle. And I suppose we can clean up the desktop now. FTP server integration. Okay. Good. Okay, so there's code up and running. This is to read data from the database. We're using our inbound JDBC adapter. The thing I posed was, what if I wanted to like process the data? What if I wanted to update the data and do something with it and then update the SQL database? Okay, so that let's tease this out a little bit. Here I'm doing an update already, but maybe I don't want to do that. Maybe I want to do it only in response to a particular thing. Okay, so for now, since we've already got this version controlled, let's get rid of the update logic. Okay, and go back to a simple query where we're doing a select and we're providing the row mapper, and that's it. Okay, so now then the next thing happens is we get the customer here. I want to do something with it. I'm just going to return the payload in this case, which is the actually, this is a good example of where we can split the data, right? So somebody was asking about how to split. We could do that right here. We could say, I'm going to given a, okay, so the result of this is a collection of T, where T is our customer. The next thing that we're going to want to do is to split the data, okay? So here, we can provide a splitter, new function that will do a split for us for a collection of T of customer, turn customer, okay? So that function, let me see here. So populate the method invoking splitter to evaluate the discovered method of the service at runtime. Okay, so method invoking splitter gives us a collection, method invoking message processor, target object method. Okay, so what's the right way to split a collection? Is there a simple way? It should be very simple. Abstract message splitter. I mean, in theory, we should just be able to do dot split. Actually, now that I think of it, let's try that. Let's just do dot split because the payload is already a collection. You should be able to get multiple messages after you've done that. So then this should now not be a list of customer, but an individual customer if I am not missing something here. So let's try that. Okay, so there's no data yet. Go to our database here. Oh, we need to delete from customer. Okay, something happened. Oh, look at that. It gave us the right thing. What's the exception then? So it did the split correctly. So what did I do wrong? No output channel or reply. Oh, okay, yeah, that's fair. So you have to terminate the flow. If you have nothing downstream, you need to make sure that you stop the flow there. Otherwise, it's going to be confused as to what your goals are. So look at that. So we split. It's okay. Clearly, we need to do something with it to handle it. So handle. And I guess what we could do is so it's correctly splitting the data. So if we let's go ahead and put another record in there. Uh, okay, so there's 3 records. Restart. Okay, so you can see it's ID 8, 9, 7, 8, 9. So it's correctly taking the data from the inbound database, which is a collection. It's splitting it into constituent objects. Now we can deal with each customer, distinctly, and then we have to do something. And here we're just logging it out and doing nothing else. Let's suppose we want to then update the database as a result of some sort of computation. So here we can use a handle call, and we're going to use an outbound JDBC adapter. Okay, so I don't know what that would be. Let's see. This is the inbound. Okay, and JDBC outbound or JDBC message handler. There you go. Yeah. So this JDBC message handler, I suppose, message handler that executes a SQL update. Okay, so this is exactly what we want. So do we want to do a batch? Well, first of all, we could do, yeah, okay, let's do that. So we'll do a bean type JDBC message handler, new JDBC message handler, passing in the data store, the data source, then the update SQL. So update customer set processed equals true, where ID equals this. Okay. Return update that set prepared statement setter, new message prepared statement setter. So we have a prepared statement, and we have the pointer to the requested message that we want to update. This will be the message with the payload of type customer. So we can say var customer equals requested message dot get payload, right? Like that, and we're going to say ps dot set boolean 1 to true. Okay, guess that execute. Do we have to do the execute, or will it do it for us? I never know. So okay. But no, it's not that. It's not boolean. It's the integer, isn't it? So 1 dot ID. Okay, there we go. That's a bit better. Okay, so that should do the outbound, the update, right? So we should be able to process a message and then do something with it and then update it accordingly. Okay, so let's try that. Column index is out of range. 1, is it 0? Oh, it's, so this does take question marks, not the mapping style. Okay. Yeah, so if I clear all this, the messages have all been processed. Yeah, they're all marked as processed. So we're able to read data, split it up, do something with each record, and then update the record, update the database. Now, this is not very efficient, right? In theory, you want to like compose all of these in like a batch. Hi, welcome. Good to see you again. Hello. So for those of you just joining, we are exploring database integration with Spring integration, and we looked at the inbound channel adapter for JDBC. So we have a query. We're doing it's an anti-pattern. We're reading from a shared database and doing integration based on that. So whenever there's a new record where process equals false, we pull the data down and we get a message. And that flow takes the message that comes in from here every second. If we'll get a collection of records. So there might be 10 records that match the select. So that gets split out into 10 different messages. Then we have a handler that just prints out the message and the payload for each one. And then we have an outbound adapter that will update the database for each record. Now, this is inefficient, right? We're doing, if there's 10 results in the select, then there's going to be 10 calls to this update customer set process, 10 different transactions, etc. So what we want is to do it with a little bit more finesse. So we want to do a batch. And in order to have a batch, we need to integrate all the records back into one thing again. So somebody was asking about split and join, split and aggregation. We're going to do that now. So SQL, which let's try that now. So we need to join these records, aggregate them. We need to get them all back into one collection. We should just be able to use the aggregate handler there because each message will have headers associated with it that tell it, first of all, in what sequence it belongs, and also what number out of that sequence it is, right? So if I'm in a batch of 5, I'm the third element in the batch of 5 elements, right? So for example, update customer set processed was false. And now Spring Integration sees the data, and you can see it says sequence number 1, sequence number 2, sequence number 3. So in that whole, and by the way, you can see sequence size, right? That's so it's saying there's 3 elements. This is the third element of 3. This is the second element of 3, the first element of 3. So I'm going to print out all the results, but then select all from customer, process equal to true. Which is kind of interesting as well, actually. Why is that working? So we're giving it, so the payload that we're giving it here is a collection of customer. And this is still doing the right thing. But it's doing the right thing by calling this query each time. So if I were to put a breakpoint here, system out calling, breakpoint. If I wanted to do a breakpoint in the execute part, the actual handler, execute update query. This one right here. It's doing the JDBC operations update. Or this one. Is it using that one? Looks like it might be doing the right thing anyway. So prepared statement. Let's go ahead and restart that and see what that gives us. Almost instantaneously. I set the results to false, but before I get a chance to even query it, it's already updated them back to true. That's really good. So where is it running that code? Is it here? I'm trying to figure out where the actual, so prepared statement is not null to array, get the operations. Is it the batch update? Is that getting invoked? We don't know. Who knows? Yes. Oh, that's really good then. That's really good. So it's doing batch updates. It's not actually doing the inefficient thing that I was worried about anyway. So it's oh, really cool. How does it do that then? What is the update SQL? Did it build it dynamically? New this.update SQL. What is the update SQL? payload equals customer. JDBC message handler. Payload is customer. Message headers. Okay. So we got all three. Wrapping update. Okay. Proxy. Looks like it's doing the right thing anyway. Neat. Okay. So there you go. It looks like it's gonna it sees all three and it's doing it within the context of this batch update, right? This is the JDBC template batch update method. And it's going through the collection of messages. Wow. What is the property that's looking for? What is this value here? Evaluate expression. It's a payload. It's an envelope of it. Okay. Set values. Message prepared statement. Okay, that's interesting. So what does this do? This is a custom thing from Spring Integration. It's a, oh, wow. Set values. Okay, so it's calling, that's this thing right here. That's what we've provided right here. It's calling this. And you can, let's see. So let's try that again. Okay, so go here. It's going to go to this. It's going to call our prepared statement. That's our, simple DB integration application. And then it goes to here. Really cool. So it's giving us a chance to set the prepared statement values, and it's doing it in a batch. So that's the most efficient way to do this, right? Look at that. So the batch size is this. It's messages.length. There's 3 messages. Yeah, that's actually pretty cool. That's really nice. It's doing it. So it's doing the whole thing within a single transaction. It's doing the query 3 different times. It's not actually, but it's not setting the whole thing. It's doing it all within a transaction. That's nice. And if you wanted to do like a batch SQL statement, so this is being triggered because we have prepared statement is not equal to null. But if you had a simple query where you just have SQL that has no parameters, then it would just trigger this flow right here where it creates the parameter source. How would it create? Oh, I guess SQL parameter source factory creates parameter source. It just creates an empty parameter source, I guess. And it's updating the batch using that. Nice. Nice. That's very cool. So, okay. So we've got this like very, very powerful mechanism to like iterate through all the data and to update them, do reading and writing. Hi, Syed. Hello. I learned something here. That's really powerful. I didn't know the support for JDBC was so like robust. That stuff is new. That batch message source. That's we saw Artem's name. Well, it's not. Artem is not exactly a new contributor, but that code didn't exist the last time I used this stuff for SQL database integration. Okay, well, anyway, good stuff. So we got the basics, right? File system integration, SQL data store integration. You could update things as processed like this, or you could do something with it and then update them as processed. It plays nicely if you do something like splitting and then processing each record and then doing aggregation. That works just fine as well. All of this is fine, but I did mention earlier that you can also do Postgres. You can treat Postgres in particular as a message queue, right? So let's commit all this. Good stuff. And let's go see if we missed anything interesting here. Message partitioning a message store. JDBC message store. Okay. So in Spring integration, they have this thing called a message store, right? And open this up again. This message store is an interface for given a UUID for looking. Yeah, this integration flow stuff is amazing. It's been here for like I don't know how to do Spring integration the old way. I wrote a book on how to do it the old way, but I've forgotten because the integration DSL, the integration flow stuff, is just so much more natural to me. Uh, it just feels right. And then you've got that, and you've got the functional reactive style in for routers for HTTP endpoints. You got that and this, and it just feels very. I don't know. I like it. I like the clean chaining of steps. Okay, and same thing for the Spring Batch job DSL. I mean, I think they all just feel very natural together now. Okay, so the message store is great for the claim check pattern. So basically, I don't want to have to send the whole payload of each message in across the wire and all that stuff. So you can use a message store to, given a UUID, hydrate that message, right? So you can store the message in a database, and then when you need the database again, you can look it up, but you don't have to send the whole thing, for example. So this is an important pattern. There's an implementation of message store backed by a data store. So JDBC message store, very, very cool. Wow, this code has been around. This is Dr. Sire, of course, who worked. He was at the time he was the lead of Spring Batch. This Spring Integration 2.0 came out in like 2010 or 11, something like that. So very old release. But anyway, yeah. So this is great. This is a message store that saves. Look at all this. Look at all this cool stuff here. You can use a SQL database as a message store. I like that. Okay, so message stores, that's interesting. We looked at the inbound and the outbound. Oh, what about the gateway? Do we want to talk about gateways right now? We could. What is the output of an insert? So let's try that. Let's try an outbound gateway example. Let's mutate this before we move on. Let's mutate this example to use the gateway. Okay. So how would that work? The way that would work is you do an insert, you write some data into the database, and then you get a response back, I guess. So right now we're doing handle and we're passing in an outbound JDBC message handler. That's an outbound adapter for JDBC. What if instead of doing that, once you use an outbound adapter, it takes your Spring Framework message and it sends it out. Where? It depends. In this case, it sends it out to a SQL database. But how do we know that worked? How do we know that what we wanted to happen happened? And maybe in this case, it's kind of like obvious. We're going to send it out to a SQL database, which will then store it, right? But what if we wanted to do some sort of request response? Maybe I send a message via RabbitMQ and I get a reply, right? Invoke an HTTP endpoint and I want a response, right? And so in this case, you need a gateway. Hello, hi, buddy. Welcome. So in this case, you need a reply, and that's where you use a gateway. Okay, so Spring Integration has a gateway for JDBC. What it returns, I don't know, but it looks like it exists. So let's see. What is the message store? JDBC outbound gateway. JDBC outbound gateway. Okay, so that looks reasonable. Let's try that. So we'll create a bean here. Okay. Return new. Then it requires a data source. Fine. And it requires an update query. So we want to, same thing as before, we're going to use the same basic query to update the downstream database. And by the way, just a friendly reminder that one of my all-time favorite features of Java these days is multi-line strings, right? So if you have a more gnarly SQL query, like for example, this one, right, with all these crazy queries, see all this? Insert into blah, 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 plus, quote, plus, plus. You don't need that anymore, right? You can just do multi-line queries. Okay, so SQL var JDBC set row mapper. So the result that comes back, I don't know what the result that will come back is, right? So before we can do a row mapper, I guess we just need to like Get the results and see what happens, huh? So set max rows, no. Set reply SQL parameter source factory, no. Set request SQL source parameter factory. Yeah, okay, that's set request prepared statement setter, right? We need a message prepared statement setter, just like before. So that's this right here. Okay. So we're gonna do an update, and then what do we get in response? That's what I'm trying to figure out, right? Return JDBC. Okay. So let's change this code to no longer use the outbound adapter, but instead to use the new gateway that we just created. So this is the outbound. Okay. This is inbound. These are unidirectional. They go one way or another, but not both. Okay. And this is the gateway, which is both. You get a request and a response. But you can do outbound, which is like you send a request and then you get the response, or you can do inbound, which is a request comes into you and then you produce a reply, right? But either way, a gateway is both directions. You handle coming and going, or going in and coming and so on. Okay, so gateway. So gateway, we'll just inject that here. JDBC outbound gateway, and we'll do integration flow. Oh, that's interesting. I'm gonna do what do I do? How do I use the DSL to use gateways? Can I use the gateway like that? Oh, look at that! I can. Haha. Um, what's going on here? Oh yeah. We'll put a great blog from uh, from 9 years ago. Hard to believe. So Spring integration, Java DSL line by line tutorial. Okay, I think this is Artem or Gary. Artem, yeah. He remembered Artem is the one who created the DSL, right? This is a beautiful, beautiful blog. So let me put that in the chat here. That's so definitely worth sharing. Okay, there it is. That get the bits. Thanks, Umbu, for sharing. Appreciate it. Okay. Okay, so what does this do? So when we get, I guess we want to see what the results of that are. So we'll create a new handler afterwards, the new generic handler of type object, because we don't know what the response will be. Amount payload. There's dot for each KV. I don't really need this one anymore. So the results that we got back here are, it's a map with all three records updated. It's a collection of maps with the key updated equals one, updated equals one, updated equals one. So I guess you just have to infer that, everything worked as you'd hoped. I don't know. It's like, which one got updated? JDBC set keys generated is true. Ooh, what does that give us now? Yes, there is a Kotlin DSL. That's a great point. And you know what? We did look at that a couple days ago, right? We looked at in our Let's Code Kotlin. How did Google know that I wanted that one? We looked at Spring integration, right? DSLs, integration. There's this Kotlin DSL. So here, integration flow, inbound file adapter, set up the polar, and then we just transform. Okay, transform again. Great. Handle. Great. Very simple, right? Very, very clean DSL that you can use to work with Spring Integration's integration flow. Check that out if you want to see an example. Okay. Good point. Yeah, we do have a very nice Kotlin DSL for Spring Integration. Very nice. Okay, so what does this thing do if we do a set prepared? So remember, we're using the JDBC template underneath the hood here. The JDBC adapters are using the JDBC template. The JDBC template has this thing called a key generator or key holder. So when you do an update, you want to get the new, like if you insert into a new row, insert a new row, it's gonna, your database will generate a unique ID if you have a primary key that's auto incrementing, as ours is. We have a serial primary key. I want to get the result of that. I want to get the ID back from the insert. That way I can update something else, right? Um, yeah. Let's see here. So what does that do? If we restart this, that's not good at all. So what we're getting here is a collection of customer. Why am I getting a collection of? I see. I don't want to aggregate. I want to send it out. Okay. Yeah, there you go. So that doesn't need to be a collection. This can just be a customer. Restart. Ooh. Okay. So there you go. You're getting, so if you do set, oh, that's actually even easier than doing it with JDBC template directly. Actually, if you think about it, right? Because you have to deal with all that key holder business. This just seems to work. Wow. Okay. So I'm reading from the inbound adapter. I'm running a query that's giving me a collection of T. I'm splitting it so that I have a bunch of messages with T individually instead of a collection of T. Then for each row, I'm just printing out, and then I'm handling it by sending it out to the gateway, one row at a time. And that gateway is doing an insert into the database or doing an upsert or something. It's updating something. And then the response that I get back is the ID, which is the newly updated ID of the record. Process equals true in the name. So I'm getting that record back. How am I getting that record back? Am I just getting the whole thing back? Like update customer, set process equals true or ID equals whatever. Oh, is that just the name? What is that? I don't even know. It's either way, very cool. Right? Like because if you look at the records here, process equals false, right? So handle new generic handler of type customer. We're just gonna log the results here, but system out before the gateway. Hey, so before the gateway, oh, there's no Boolean there. Yeah, okay. So it's getting the process equals true from the SQL database. It's like, that's so cool. Okay, so yeah, there you go. You've got the ability to send a request, send a response, etc. So you get a bidirectional communication with the gateway. I quite like that. That's nice. But the thing is, we're still polling, right? We're still polling, and the polling, it's fine. Um, Pretty fast. It's one message per second, basically. Um, let's see. Hold on. BB in and out. It's one message per second, but sometimes I want instantaneous notifications when something has changed, right? And so Spring Innovation, I talked about this in a video before, but there's a gentleman named Raphael Winterhalter, who's he did a Java Advent calendar using Spring integration as a message queue. Uh, so Raphael Winterhalter, he's the person who created ByteBuddy. Where's the wow, lots of great comments there. I just noticed. So That's him right here. He's the creative person who created Byte Buddy. Just an amazing engineer. He's also been on the podcast, by the way. If you want to talk to him or listen to him on the show, uh, he lives in Norway. He's German. I guess he's Norwegian now, but he's a Java champion and just an amazing human being. And he built support for using a message store. Remember, we just talked about message stores. Um, he built support for using the Postgres message store uh, to take advantage of a new feature a relatively new feature in Postgres called Listen Notify. Okay, and so basically, Postgres can act as a message broker. So you create a table, and then as soon as there's any change to that table, it'll immediately tell any clients about that change. You don't have to pull; it'll push the message, just like brokers like RabbitMQ or Kafka or JMS, will do. Okay, so I'll just revisit that code because it's apt, but it's not exactly the same thing. So that's code. We have a Coffee Software Show repositories, Spring Integration, Postgres, Pub Sub. Here's this. This is January 3. This is before the channel was even up and running. And it's hard to believe it's already almost April. I mean, spring is here. We're already in spring. Spring Framework uh, 1.0, like I said, it was in spring in 2004. But okay, so Spring integration. Okay. Docker Compose. Do I need anything special there? I need Postgres 15 Bullseye. Is that what I'm using over here? Let's Control C that. It's the latest. So I'm using the latest, but you need 15 Bullseye, and then everything else I've just set to be Postgres, Postgres, Postgres. So we'll just run this Docker Compose up. And we're going to update my old code from way back in January. We'll say subl consumer. This is using Maven. Why is it using Maven? 5. Okay. So all of this would be trivial to do in Gradle. I should just fix that off stream. Yeah, there's no reason this couldn't be Gradle. Okay, so basically, I name Maven F. That's gonna just build everything quickly so we can download all the bits because stuff has changed, obviously. Ooh, I saw a failure there. Okay, let's see here. Idea, producer, XML. XML. Okay, Postgres. Yeah, that's a good point. You need to have this on the compile time class path, not your runtime. Okay, we need the schema, source, main, resources. Basically, Spring integration ships with this schema about Postgres. You need to enable all of it. You need to run all of it, including this stuff especially. So tweak that over here. Okay. All right, there you go. So there's this. There's your schema. I'm going to run that schema on my database directly. I'm just going to pipe it right in there. What could go wrong? It's going to be fine. Okay, so you can see we've added considerably to our database schema here. We've added 5 tables in one sequence, okay, all on the surface of Spring integration messaging. And now we've got our producer, and the producer uses a message store to store databases, store messages. Remember I told you about that message store to support the claim check pattern. The claim check pattern is basically given an ID, just like when you check your coat uh, at a restaurant or something. You check your coat to be stored. They give you a ticket, and then you give them the ticket. They give you back your coat. Same thing here with a message. I don't want to perpetuate. I don't want to move the message through the entire flow. It might be heavy. I might have a lot of data attached to it or whatever. So I give it to the claim check. I give it to the message store. It gives me my ticket, which is an ID. And then later on, I can come back to it and say, hey, here's my ID. Give me my message back, right? The whole thing. So we're going to use one that's backed by JDBC, which we talked about earlier. This relies on the fact that we're using JDBC. We've got a message channel now as well. And this message channel is backed by this JDBC channel message store. So any messages that get created will get created and be passed through this message channel, which will then store things in the message store. And then finally, we're going to inject our channel, right? And we're going to send a message, any message, just hello Postgres, right? That's the producer side. So now let's go look at the consumer side here. Desktop, Spring integration, Postgres pub sub, CD consumer, idea, POM XML. Okay, so this is the consumer side, same basic trick. So remember, the messages are being stored in Postgres. So from a consumer perspective, we want to get notified whenever there's a new change to that table that's being used to store the messages, okay? So we have a bean of type message store here as well, just like before. And here we're saying, save the data, messages will come from that database. We have a message channel, which is, again, we're using the message store to subscribe to the data, right? We have a Postgres channel message table subscriber. This is the thing that does the interesting thing that we want, which is we have a supplier that gives us a unique dedicated connection to our SQL database. That's what this Lambda is doing, right? Using the driver manager to get a connection directly instead of using the connection pool, because the connection pool will automatically shut it down, right? A Hikare or whatever will automatically time out a connection if you're not using it. We need this to stay alive forever, right? It's going to be dedicated so that we are constantly able to get the latest messages. And this subscriber is just going to listen for messages on the message store. And as soon as a message comes in, we can handle it. So I'm going to say, okay, when messages come in basically this supplier, this channel will subscribe and listen to new messages. When those messages arrive, they'll be sent on the input channel here, and we can process them here. I'm just going to log out the messages here. I could do the integration flow instead, right? Integration flow, inbound SQL messages flow, right? Return integration flow. But from in, I'm going to inject the message channel, I suppose. Okay, so we'll say in dot handle, new generic handler, new handler, whatever, new message handler. Here you have the basic same contract of a message. I'm just going to print out the message. Same basic flow. You've seen this before. So let's start the consumer. Okay. Oops. Okay. There's that. And then what about the producer side? You need to specify your SQL data store as well. We'll restart this. So remember, the producer sends a message on the channel. The consumer is listening to that message on the other side. So we're using a Spring integration, and we're writing code in the same way that we always do with message channels and messages and handlers and all that. Uh, but like this is the consumer. Let's go ahead and restart this here on the producer side. There you go. So you can see the message over there again. Restart this again, etc., etc. Instantaneously, right? There's no polling involved here. It's just as soon as there's a message, we get it over there on the other side immediately. Isn't that cool? Like you can use Postgres as a message queue. So if you want a SQL database, you can use Postgres. This is a specific thing for Postgres. It's called listen notify, right? It's not a generic SQL thing. Listen notify PostgreSQL. So listen notify, and you can generate notifications basically on a logical channel in the SQL database, in the Postgres database. So listen notify is unique to Postgres, right? But we're taking advantage of it here so that you can treat your SQL database as your broker. Daniel says, I used Eclipse for a long time for this stuff, and it's a pain to get it working. Recently switched to IntelliJ, and you love it. Well, that's good. I mean, all things are good. Right now, as Java developers, we have so many great choices. Visual Studio Code is amazing. IntelliJ is great. Eclipse is still great. I mean, there's still lots of options. I'm just used to this in IntelliJ, but I've given up the idea that I'm right or wrong. There are just so many good choices now. You're not wrong or right using one of them. I want to get into Visual Studio Code. I know the good Dr. Sire, right? Who's one of the best engineers on the planet. He's one of those people that he's just amazing. I love the way he works. He just says I'm going to do something and he does it. And so I try to be like him. So like this year, I'm trying to use Gradle, and it's okay. I miss Maven, but yeah, he uses it all the time, and he's using Visual Studio Code. He just decided to start using it, and so that's his tool of choice. And there was a time when he was just using Emacs, and he's like, again, one of the best engineers ever. So he can write any Java code you want. He can build amazing things. So the fact that he's willing to get rid of the main tool by which he creates that amazing work blows my mind. All right, my friends. Yeah. I think we're in a good place. I think we covered a lot of things you can do with Spring integration and your database. Now, again, except for the last thing where we use Postgres in particular for SQL, not for shared notifications for pub sub. I don't, you shouldn't be querying databases unless it's your own application. Like if you're using the JDBC inbound adapter to talk to if you're in a microservice and you're listening for new messages by polling your database, and it's an Oracle database or something like that, that's fine. But if you're sharing the database, if your database is the SQL schema is a shared, both sides have to agree on that shape, I think that's going to be a recipe for disaster. And remember what we talked about the other day. We talked about architecture informs your optionality, right? What I'm trying to, or rather, optionality informs my architecture. What I'm trying to have the option for, that's what I build for today. If I want the option tomorrow to do a thing, I build for that today, right? And when you open up your database and make your schema the thing on which you on multiple sides need to agree, you're just asking for trouble. I would not do that. But if you're in the same service, if you are building code and you want to just maybe you've got a web app and you want to you've got a stream, right, a chat or something. Okay, great. You create a WebSocket in your code and you create an inbound adapter from Spring Integration to constantly pull the database and get you the new data, all in the same JVM project, right? That's fine. You already had access to your database, but you shouldn't be exporting your database schema as a common ground for other services. You should export the WebSocket, which you are feeding with Spring Integration. Friends, this has been fun. I hope you got something out of it. I'm going to call it good. I think we covered a lot here. It's Friday. I hope you have a wonderful Friday. I have a video coming out next week, like a pre-produced, polished one. And I'll be on vacation. It'll be fun. So, we'll see each other, I think, probably. But and also I have a meeting I have to go to. There's a big meeting, like I gotta get to it. I just remembered I gotta join that meeting next week virtually. Uh that'll be fine. All right. All right, my friends. Have a great one. Have a great weekend. Have a good day. See you all next time. Thanks for hanging around. I'll check in all the code online and so on. Bye, everybody.